slope-intercept form of a linear equation. Y equals mx plus b. That's the thing we're going to remember till we're 107 years old, right? You won't remember your name, but you're going to remember y equals mx plus b. So how do you write an equation of a line if you have a graph? So the first thing I need to know is the slope. How do I find the slope of this line here? How do I do that? Yeah, let's write the formula out. The formula for slope is delta y over delta x, which means y2 minus y1 over x2 minus x1. So I've got 2 points here, so I can just substitute in. As you recall, just name one of them x1, y1, and one of them x2, y2, so you know what you're subtracting. And you just replace. So negative 2 minus 4, 3 minus 0. Check me, make sure I'm doing it right here. I'm getting a slope of negative 2. I always do that check. If my number comes out negative, I look at my line. Is that a negative slope there? Yeah, so it's just like a little sanity check. What was another, maybe a quicker way you could have done it to find the slope? What's a quicker way? Yeah, so I'm looking for nice corners where it really crosses. I go down to right 1. So I go down to right 1. That's negative 2 over 1. I can get my slope that way as well. So sometimes it might be a little faster just counting boxes, but no problem. And then what is the point slope formula? I know I really pushed this last year, but I don't know if all the teachers did, so let's see if we all know that. Maria, what's the point slope formula? Y minus y1 equals Anybody not work with this so much last year? That we did it the other way? Yeah, I'm forcing you a little bit to try it this way. I like this one because I think it sets you up better for things you're going to be looking at in Algebra 2. So see if you can use y minus y1 equals m times x minus x1 rather than substituting back into y equals mx plus b, just so you have both of those tools in your tool belt. So we pick a point from the line. Which one should we pick? Now, for the sake of argument, I'm picking 3, negative 2. Right? I can pick any point I want on the line. I'm going to pick 3, negative 2. And then I do y minus y1. Well, here's x1, y1 in this situation. So y minus negative 2. Well, a minus minus is a plus, right? My slope is negative 2, x minus x1. So this is point slope form. If you just wanted the equation in point slope form, I can stop right now. Usually we go back into slope intercept form. So I'm going to do my distribution. Right, that's negative 2x plus 6. Subtract the 2. And I'm getting y equals negative 2x plus 4, which I believe is correct. One thing I like to do to check, if I can, is I know the slope is negative 2. You can plug the other point in. Now this one I actually could have done a little bit quicker. What's the quick way I could have handled this? Absolutely. If they're giving me the y-intercept, I figured out the slope already. If you know the slope and you know the y-intercept, you could have just said, well, if m is negative 2 and b is 4, right, my y-intercept, it's just going to be y equals negative 2x plus 4. So if you know the y-intercept, these are really easy. If you don't know the y-intercept, you can use point slope. Yeah. Okay. Graphing linear equations. This kind of, we went over this during the review there, the homework answers, but let's see if we can remember how to do that. There are a couple of ways to handle this. The first way is what we did when we did that homework question, was we put it in slope-intercept form. So we start with our original equation. I want to solve this for y. So I'm going to subtract 3x from both sides. And then I'm going to divide everything by 4. I think I did that one right. What do you guys think? Right? So I have a slope of negative 3/4, and I have a y-intercept of 3. So you graph the y-intercept, and then you can go down and right, or you can go up and left, either way. So I go down 3, right 4, and then I can connect. Yeah? Now there's another way we can approach them. Sometimes, especially one like this, when they're given to me in standard form. Remember standard form? ax plus by equals c. Remember that? Go like this. you remember. Okay, awesome. Very often, when I see it in that form, I will use the intercept method form of graphing. Anybody remember how to graph using intercepts? We got very quiet. Do you remember? Remember, Asa?
You have to find the line.
You have to find the x-intercept and the y-intercept. How do you find an x-intercept? How do you find an x-intercept? You set the y to 0. And how do you find the y-intercept? You set the x to 0. So let's see. If I got 3x plus 4y equals 12, remember the y-intercept, or the x-intercept, let's start with that one. It's going to be x comma 0, right? So y is 0, because it is. On an x-axis, the y is 0. So if I substitute in a 0 here, it's like this goes away. And so x equals 4. So x equals 4 is my x-intercept. And okay, it's right here. And then I can find the y-intercept. The y-intercept is always of this form, 0y, because to be on the y-axis, your x value is 0. So I'm going to plug a 0 in for the x. So that's 4y equals 12. So y equals 3, and I'm up here. So I could get 2 points that way. Either way is fine. I will sometimes do that, especially one like this where it looks so easy to just set them equal. But either way is fine for graphing. Write an equation of parallel lines. Now we did this as well. Write an equation of a line that passes through point -1, 1 that's parallel to equation y equals 2x minus 3. And I kind of like the visual, which I don't think I have the visual on here, but let's just draw a quick picture. Y equals 2x minus 3 looks a little bit like this. So point 1, -1, I don't know where that is relative to this. But let's say it's here. I'm just looking for that line that's parallel to it. And so the main question we have with parallel lines is we need to understand how their slopes work. Parallel lines have slopes that are equal slopes. I always think this is the easier one to kind of remember, because if you think of what slope is the tilt, right? It's a way to give a number to the tilt. So a parallel line is going to be tilted the same way. They have that same tilt. So what's the slope of my given equation? What's the slope of the equation we have? Yeah? 2. So I'm going to write that here. So what's the slope of my new line going to be? 2. Same thing. Now I need a point on my new line. Do I have a point on my new line? This one. Right? My new line is going to pass through that point. Write an equation of a line that passes through this point that's parallel. So they gave me a point. So if I have a point and have a slope, what should I use? Point slope. So I'm going to do y minus y1 equals m times x minus x1. This is my x1, y1. Y minus 1 equals m times x plus 1. Y plus 1. Subtracting a negative. Minus is plus. We'll do a quick distribute. And then add 1 to both sides. Getting y equals 2x plus 3. What I do to check it is, first of all, make sure the slope is the same. This has a slope of 2, this has a slope of 2. I get parallel lines. And then I put my points in. If x is -1, 2 times -1 is -2. -2 plus 3 is 1, which is what I'm expecting. I just make sure that I do have an equation that goes through that point. It's just a little check to look for errors. Questions on that? Do you remember it? Awesome. So that's parallel lines. Perpendicular, slightly, a little bit more to think about. Write an equation of a line that passes through this point 2, 3, that is perpendicular. So if we want to do a quick sketch of what we're thinking about here, y equals -2x plus 2, something like that. And then point 2, 3. So I'm actually looking for this line right here that is perpendicular. That's the line we're trying to find. So let's see. Perpendicular lines have slopes that are what? Negative reciprocals. Another way to say that is if you multiply the slopes of perpendicular lines, you get -1. So you can also say the product of the slopes is -1. It's another way to think about it. So now, when I look at my slope of my given equation, equation, which is what? It's the slope of my given equation. Yeah, what is it? -2. Okay. Now I want to be perpendicular. So what is the slope of my new line going to be? 1/2. Tell me how you got that. You multiply -2 by 1. Oh, okay, because if you multiply them at the times, you get -1, so we know it's correct. Or you can take the negative reciprocal. Change the sign, invert numerator, denominator. Questions on negative reciprocal? Okay, awesome. Points on the new line. My new line is going from 2, 3. So there's my point. I have a point and I have a slope, point slope. So y minus y1 equals x minus x1. So this time my y is 3. 1/2 x minus 2. Y minus 3 equals half x. Half times -2. -1. Add 3. Plus 2. Y equals half x plus 2, I hope. Let me just do a quick check here. First of all, are the slopes negative reciprocals to the original? So they are perpendicular. Let's see if it goes through this point. Half of 2 is 1, plus 2 is 3. So that point does fall on that line. So it gives me confidence I've got the correct equation. So what do you guys think? Who has a question? Who's like, just give me an up, middle, down, just where are we? Awesome. If you have a question, please don't hesitate to ask. I don't want you to get lost on this stuff. There are a couple of U-tries here, 4 of them. Do you guys want to try those? Okay, so hopefully we all got these right answers. Again, last chance if you have any questions. Okay. Moving on then. Now, this is algebra. What's the name of this class? Geometry. So it wouldn't be geometry without some theorems. Okay, yay. Here we go. If 2 lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. Does that make any sort of sense? First of all, linear pair, remember what that is? The linear pairs, you got the straight line and like 2 adjacent angles, right? So if these angles are congruent, what must each angle be? What must they be? They must be 90 degrees. If they're both 90 degrees, then they are congruent, right? So what do I know about when you form a 90-degree angle with another line? Intersecting lines that form 90-degree angles, we call that perpendicular. So that makes sense, I think. Don't like this if it makes sense. Awesome. All right, what else do we have? If 2 lines are perpendicular, then they intersect to form 4 right angles. Well, let's see, where's that coming from? We know that if lines are perpendicular, by definition of perpendicular lines, right, makes 1 right angle. So can I figure out why the other ones are? Well, first of all, how about this one? Vertical angles. And then how about these? Linear pair postulate, right? So they'd be supplementary. So they'd have to be 90 as well. So, okay, great. If 2 sides of 2 adjacent, there's that word again, adjacent acute angles are perpendicular, then the angles are complementary. So remember, adjacent means next to, they share that, right? So you've got 2 adjacent angles, and they're both acute. If they are perpendicular to 2 other sides, what else can they be but complementary, right? They would have to be. Because since these are perpendicular, they're 90 degrees, and then it looks like we got a little angle addition postulate. If you add up those 2 things, they're going to be 90 degrees, which is definition of complementary angles. What else do we have? The perpendicular transversal theorem. If a transversal is perpendicular to one of 2 parallel lines, then it is perpendicular to the other. Right? So here is one line, you've got your transversal here, it's perpendicular to it. Why is it going to be perpendicular to this one as well? How come?
Lines H and K are parallel.
Yeah.
And
This is like J up here, yeah. This
line
one's
J
J.
is perpendicular to H.
Yes. postulate or theorem would you like to use? Corresponding angles, maybe? Yeah. So this one and this one, they're corresponding angles, right? What do I know about corresponding angles of parallel lines? They are congruent, correct? Isn't that postulate? Corresponding angles of parallel lines are congruent, right? You don't tell me that was easy. Thomas, turn around.
Okay.
Good. So these are congruent. That means it's 90. If it's 90, they're perpendicular. These almost are stating the obvious. Okay, lines perpendicular to a transversal. In a plane, if two lines are perpendicular to the same line, then they are parallel to each other. Well, this is kind of working backwards from this. So I've got two lines that are both perpendicular, line P. Why are these parallel? Because now I can use those converse theorems. So if I have two corresponding angles that are congruent, then the lines must be parallel. That is the converse to the corresponding angle postulate, isn't it? You all said no. Right, hello? Okay, we're there. So what I kind of did was, I have like big proofs on these. I got these huge proofs, but I figured we just talk them through. So if you're interested in the details, I do have these online. My flip charts are on my class summary if you really want to see the detail of them, but I think we talked through just the process, how do we get there. So they're interesting to look at, but I have so much I'd love to do today. So we're going to try this now. So try the U-tries. Using these new theorems, on page 2, I've got 3 questions for you to work on. So try these based on the new theorems. Let's talk about these a little bit. How come I'm concluding for number 1 that the two angles, 3 and 4, are complementary? How come I can conclude that? Why can I conclude that?
Well, angles ABC and
ABC.
ABD are congruent.
Okay.
And if they are a linear pair, that means they have to have congruency, and they're congruent or complementary.
Right, that's that first one. If two lines intersect to form a linear pair of congruent angles, then they are perpendicular. So these must be perpendicular then. So 3 and 4 are complementary. Why? Because they add up to 90 degrees, right? Excellent. All right, how do we find this value of x? Okay, Emily, tell me how you get what you get. Right. If one is 90, then they're all 90.
So, 2x plus x is equal 90.
Okay.
And then,
Now we just solved that. Excellent. Right. So again, we're using some stuff we're learning here. Now determine which lines of any must be parallel in this diagram. So I chose those, but I didn't choose all of them. So I'm claiming that P is parallel to Q. I'm claiming this, and I'm also claiming that S is parallel to T. But I'm not making any mention of U. So why? Am I right? And why is that? Yeah.
because of the relation with
This one? So you're saying this one I can't include. Now these have to be parallel because I've got this going, right? So they're parallel or perpendicular to the same line, therefore they have to be parallel. Now what about these two? How come? Well, yeah, and we can use, I guess we could, what's that theorem? I gotta look it up myself. If transversal is perpendicular to one of two parallel lines, then it's perpendicular to the other. That's the one, or am I doing the other one? They're perpendicular to the same line, that's why. These two are perpendicular to the same line, so therefore they have to be parallel. But what's wrong with this one again, Michelle? What's wrong with that one? Right, we can't assume that. Now, we can't just go by looks. It kind of looks like it's perpendicular, but it could secretly be tilted a little bit. We don't know. It could. So just because it's drawn a certain way, we can't make any assumptions. So we can't assume that U is parallel to S and T. We just don't have enough information. Any questions on that? Awesome. Whoops. Okay, distance between a point and a line or two lines. Let's see, I feel like I stripped one. Yeah. So the distance from a point to a line is the length of the perpendicular segment from the point to the line. So if you have, let me see if I can put it here. Here's a line, That's how I can find distance. The distance between two parallel lines is the length of any perpendicular segment joining the two lines. So again, they have to be perpendicular, that length. That's how far apart perpendicular lines are. And you use the distance formula to find the length of a line segment, right? Who remembers the distance formula? Oh, really? That's it? Nisha, what is it? Squared plus y minus y1 minus y2 squared. Right. And remember, this is just the Pythagorean theorem. So this is like the square root of a squared plus b squared. And then how do you find the distance? You know, that's the Euler postulate, the distance between the x's, the distance between the y's. So yeah, it's back. I thought we were done with it. No, it's back. So let's see, I want to find the distance between these two lines. And I am on page 3 here. The distance of between the lines. I want a perpendicular line between the two. Oh yeah, okay. So let's see, what is the slope of these lines? That might help us first, right? So what's the slope of this line? Well, where do I have a nice, this is one right here. 1, 2, 3, 4, 1. Down 4 left one is the same as up 4 right one, which is 4. So this one is 4. If they're parallel, they sure better have the same slope. Let's make sure. 1, 2, 3, 4, 1. So both of them have a slope of 4. So what's the slope of my perpendicular segment? Yeah? Negative, right? Because I'm the opposite sign. Take the reciprocal. You multiply those two things and get -1. I know that's right. So I'm going to start at one of the points here. Let's see, how does that work? You go down 1, right 4. So this is the perpendicular lines. Luckily, it ends on some nice points here. So what are my points here? So here I am at, what are we listing here? 0, 0. And this one is 1, 2, 3, 4, -1. So these are my points of intersection for both. So can I find the distance? I have 2 points. I want the distance of this segment, and that will be the distance between the two parallel lines. So let's see. The distance is going to be square root of the distance between the x's. 0 and 4 are 4 apart, squared, plus the distance between the y's. 0 and -1 are 1 apart, squared, equals the square root of 16 plus 1, equals the square root of 17. So if they want the answer in simplest radical form, I guess I'm done. Can I simplify 17? No, I still have the square factors in there. If they say round to the nearest tenth, which I believe it does, then I just put this in my calculator. It'll be 4.1 to the nearest tenth. And that is the distance, whatever units we're using for this. Say it again, if you read it. This is, it's a wavy equals. It doesn't look so good, does it? A wavy equals means approximately. Approximately, yeah? Well, I used my slope of -1/4. So I went down 1, right? Right 4. And luckily I landed on a point. So it was a nice easy point to do. That's not so bad. Or is it? Okay. Let's try this one. What's the distance between the graph of the line y equals x plus 1 and 0.41? So this is problem B on page 3. And then round to the nearest tenth. So first let's graph this line. It's a pretty easy line to graph. Y equals x plus 1. What's my y-intercept? And then what's my slope? 1. Up 1 and over, right? So I'm going to graph the line. You should too. That's done. Now find the equation of the line through points 4, 1. Because my other point is 4, 1. 1, 2, 3, 4, 1. So I need a perpendicular. That's how I'm going to measure that distance. So let's see, what's that equation going to be? Or what's the slope going to be even? Yeah?
So if the slope of the first line is 1,
is gonna be what? And then if I want the equation, y minus 1 equals negative 1, x minus 4, y minus 1 equals negative x plus 4, y equals negative x plus 5. So 1, 2, 3, 4, 5. I mean, you could also just use slope. My slope is negative 1 here, so I can just kind of see that I do have this point of intersections, right? Do the lines intersect? They do. Where do they intersect? At 2, 3. Okay, so what's this distance? Well, I know this one is 4, 1. This one is 2, 3. I need the distance between them. So I'm going to find the distance between 4, 1 and 2, 3. Square root of. What's the distance between 4 and 2? 2. What's that squared? What's the distance between 1 and 3? Distance between 1 and 3. 2. Square that. And I'm getting the square root of 8. Now, if they want this in simplest radical form, I can reduce that, right? Y square root 8 2 rad 2. It is, right? How come? How come? Because that's 4 times 2. I can take the square root of that guy. So I'm here. So that's fine. If it says, give me the exact distance, that's your answer. That's an exact distance. Usually, though, we don't speak about 2 rad 2, at least not in this context. What's the distance? So we run that through our calculator, and that's approximately, if I did it right, 2.8, I think. Yeah? Okay. Questions on that? Because you have to try it next, so are there questions? No. Okay, go ahead and try it. We've got a couple of them for you to try, so go ahead, give it a shot. You may have used different points than me. I figured out that my slope is negative 1 for both these lines, which means to get a perpendicular through, I would need a slope of 1, because 1 times negative 1 is negative 1. So I picked a point. Now, you can pick any point you want, really, but I went up 1, right 1, up 1, right 1. So these 2 points are on the perpendicular, and you have to be perpendicular to find the distance. So I used 2, 0, and this one is 4, 2. And I use the distance formula to get there. Questions on that? Questions? No? Did we get to the second one? Find the distance between the given point to the given line. And I can show you what I got. Approximately 6.7. Anybody get that? Did we not get that?
I did.
Okay, so did we not get to the question yet? Alright, well, you can finish it. This one, I actually went by 2's here because it looks like I didn't have enough space. So y equals negative 2x plus 7. Plus 7's here. And I gotta go down to right 1. I don't know, I've got some line going on here. At point negative 6, 4. So I basically want this distance here. How do I do this one? I found the equation of the perpendicular line. So let's see. So the slope's going to be 1/2, a negative reciprocal of 2. So y minus 4 equals 1/2 x plus 6. Y minus 4 equals half x plus 3. So y equals half x plus 7. So that's this. And I was able to kind of make my line go through here somehow. And I could actually see where my point of intersection was. So from negative 6, 4, the point that was the same was 0, 7. What? What did I do? What happened? Oh, you're right. That's why it was wrong. That was better, wasn't it? Negative 6 and negative 4? Plus 6. Yeah, that's better, right? Okay, so I want to find that distance.